So here task 2 prediction using unsupervised machine learning. The problem statement from the given iris dataset: predict the optimum number of clusters and represent it visually. So here is the iris.csv dataset. It contains IDs, sepal length, sepal width, petal width, and species. So now the Python implementation of K-means algorithm is done in the following steps. First step is data pre-processing. Second step is finding the optimal number of clusters using the elbow method. Third step is training K-means algorithm on training dataset. Fourth step is visualizing the clusters. So we are going to go through each step. Step number 1 is data pre-processing step. So in this step we are going to go through 3 stages in data pre-processing. First one is importing the libraries. Second one is importing the dataset, and then the third thing is extracting the independent data variables. So in the first part of the data pre-processing step, we are going to import the libraries as a code is given below. And the second part, we are going to import the dataset from the iris.csv file as shown in the code here, which will output the following output. And over here we are going to print the target names, which is output over here. In this part of the code, it displays the first 5 target lines. In the third part of the first step, it is data extracting independent variables. Here we don't need any dependent variable for data pre-processing, as it's a clustering problem. So we are going to add this line for extracting only the 0th, 1st, 2nd and 3rd feature, because we need only 2D plot to visualize this model, and some features are not required, like IDs are not required for this cluster. So this output is shown over here. So in the second step is finding the optimal number of clusters using the elbow method. So in the second step, what we are going to do is we'll try to find the optimal number of clusters for our clustering problem. So we are going to use elbow method as discussed above. So we know that the elbow method uses WCSS concept to draw the plot by plotting WCSS values on y-axis and the number of clusters on the x-axis. So we are going to calculate the value for WCSS for different k values ranging from 1 to 10. So below is the code for doing so. So it's shown over here. Here we are going to initialize the list for the values of WCSS, and using the for loop we are going to iterate from 1 to 10 values, and we are going to calculate the square error using this function, and then we are going to plot WCSS here against k-mean values, and this results in a line graph allowing us to observe the elbow over here. So this we can see that the elbow method this creates the optimum clusters is where the elbow occurs. So WCSS doesn't decrease significantly with every iteration. So here we are going to see the optimum clusters. So we are going to choose a number of clusters as 3. Now we are going to move to the third step, which is training the K-means algorithm on training dataset. So now as we have got the number of clusters as 3, now we are going to train the model on the dataset. To train the model we are going to use the same lines of code. Instead, we are going to use I value as 3, and we know that 3 clusters are going to be formed in this training k-means model on the dataset, or it's also creating the k-means classifier. So this is shown in the code below over here. Now we are going to go to the step 4, which is visualizing the clusters. So we have seen that in the last step the visualization of clusters is done. We have 3 clusters of our model. So this is going to be plotted using the scatter plot function plt.scatter of matplotlib. So it is used over here for visualizing the clusters on the first 2 columns, and then it is shown over here in this diagram. So the output image clearly shows that there's 3 different clusters with 3 different colors. The clusters are found between the parameters of the dataset. We can change the colors also and the labels according to our choice. So we observe that the cluster 1 is the iris setosa of the target property, which is clustered around this centroid over here, and then there is the second cluster iris versicolor, which is clustered over the yellow centroid over here, and we are seeing iris virginica, which is it is shown in green color, clustered around this yellow centroid. So we are going to evaluate this performance of this model using this code below, and we got the accuracy of 0.89. So we can conclude that 3 is the optimum number of clusters required to evaluate this model, and the accuracy obtained is 0.89.